Okay, problem 8-82 for integrated 3. And the problem says, after finding out that her kitchen does not conform to industry standards, Lashaya is back to the drawing board. Where can she locate her sink along her counter in the top of the diagram? So there's a diagram. I wrote all over my diagram, so I wrote a new one. Where can she put her sink along here? Like, you can move this point so that its distance from the stove, and this thing is the stove, I'll put S, and this is the fridge. So that the distance between the stove and the refrigerator is as small as possible. Will this location make her perimeter less than 26 feet? Show all work. So in 8-70, they had us, find the perimeter of this triangle that I got with the dotted lines here and see if it was more or less than 26 feet. So in this one, they're saying that here's the stove, here's the fridge. We can put the sink somewhere along this counter here, and we want to put it in such a way that it minimizes the, this hypotenuse plus this hypotenuse, the sum of the hypotenuses. So it turns out that this is, like, how are you going to know where to put it? Like, you could just do a bunch of calculations, like keep moving it and guess and check. I think the easiest way to think about this is that the shortest distance between 2 points is a straight line. This is 6 feet, and this is 3 feet. If I were to flip this 3 foot, let's just flip it up here. Just for fun, just humor me. Say that's 3. And then let's try to connect if I were to flip it so that I had a straight line here, that would be the shortest distance. So, and in order for that to work, well, it looks like this needs to get scooted over some. Let's scoot it over a little, give you an idea. Let's just scoot this over here. And then where's my straight edge? Basically, what we're going to find out, and if you go on the homework help, if you go to cpm.org and go to homework help, it says students need to make the two right triangles similar. They have to realize that the two right triangles have to be similar, and then you can use proportions. So why would they say that? Why does this left-hand right triangle have to be similar to the right-hand right triangle? Well, it has something to do with these two angles right here. If I wanted to make a straight line by like flipping this triangle across this countertop line, if these two angles are equal, then when I flip the triangle up, these vertical angles are equal. So we've never talked about this in our Integrated 3 class, but there was a problem with 2 speakers and some speaker wire, and actually the problem that you had in Integrated 2, if you remember it, it looked exactly like this, except for that it was upside down. It was more like this. This is 6, this is 3. You need to connect these speakers. You need the wire's expensive. So where does this point go? And you end up having to do a problem exactly like this countertop problem. So, why am I erasing that? So if you remember that from last year, that's kind of what would give you the idea to make the proportions, to make these proportional. But I'm just going to have to tell you, you're going to have to believe me that if I assume that these two triangles are proportional, then I can go ahead and do the problem. So what I would do, if these are equal, these angles are equal, then that would make this one of the sides, like we can just call this side x, and we can call this one 11 minus x, and then we could just make a proportion. So we can say maybe 6 is to x, as 3 is to 11 minus x, and then we can solve for x, find out what x is. So 3x equals 66 equals 66 minus 6x. So if I add 9x, 66, divide by 9. So x equals, I think I'm going to reduce it by 3's. 3 goes into 66 22 times, and 3 goes into 9 3 times. So x is 7 times, x is 7 and 1/3. So over here I got 7 and 1/3. And so what's this side? Well, it would be whatever 11 minus 7 and 1/3 is. So let's see, 11 minus 7, 4, I think it's going to be 3 and 2/3. So now we have some sides of some triangles. And now we can use Pythagorean theorem to find these two parts. So I can say 3 squared plus 3 and 2/3 squared equals c squared. And I actually already did some of that work. I got 4.74 for this piece right here. And then over here I can say 6 squared plus 7 and 1/3 squared equals c squared. And I did all this, I put it in my calculator, and I got 9.48. So I have these two sides, and then I was going to do something crazy, and I'm so glad I didn't. Well, I did, but then I got it wrong, and then I went back and tried again. I was going to use Pythagorean theorem again to find this, but I realize now that this right here doesn't, it looks like a 90-degree angle, but it might not be. So I can't use Pythagorean theorem with this side and this side and this side. So then I wondered, well, I don't have any angles, what am I going to do? So I'm thinking, I actually talked to Mr. Hendricks about it, and he went like this. This is, from here to here's 3, which means from here to here's 3, which means from here to here's 3. So this is 3, and then we know that this dotted line I just made is 11, right? So now I can use Pythagorean theorem. I just have to use it with the proper triangle. Okay, so I'm going to use 3 squared plus 11 squared equals c squared. So that's 9 plus 121 c squared. So I think that ends up being 130. Yeah, my calculator. I'm going to probably get a decimal for that. See what that is. So that's about 11.4. And then I'll just add them all up. So I want to see 9.48 plus 4.74 plus 11.4. Plus so I got about 25.62 is the perimeter now. So I think that's all they were asking us. So the sink should be located 3 2/3 feet from the right edge of the counter, or you could say 7 1/3 feet from the left edge of the counter. Either way. And then the perimeter is now 25.6 feet.